Hey, let's look at these last couple of problems. It looks like they're a little bit simpler, so hopefully we can get them both in the 15-minute window. This first one is just taking the systems of two equations, two unknowns, and writing as an augmented matrix, and then using row echelon transformations to Gaussian eliminations triangular form. So let's knock that out. First, let's write this as an augmented matrix. It's the coefficients 7, -2, and -2, 4. Augmented by the solution column 3, -9. All right, I like to take this 7 to a 1 first, right off the bat for a system of two equations, two unknowns. So this first position, it needs to be a 1. So I'm going to multiply 1/7 times row 1. That's the same thing as dividing row 1 by 7, but I usually multiply. So row 2 doesn't change. I'll just rewrite row 2. -2, 4, -9. Row 1 is the only thing that changes right now. 1/7 times 7 is 1. 1/7 times -2 is -2/7. And 1/7 times 3 is +3/7. So it's easy enough. Now I usually get this -2 to be a 0. I'm going to use row 1 to do it. 2 times row 1 plus row 2. Only row 2 changes. Only what you're adding to changes. Row 1 stays the same. So row 1 is 1, -2/7 and 3/7 still. And row 2 changes. 2 times this 1 plus the -2. 2 times 1 is 2 plus the -2 is 0. That's the 0 we were looking for. 2 times -2/7 is -4/7. Let me write that down over here, scrap work. And then 2 times -2/7 is -4/7 plus 4. I have to multiply 4 by 7/7 to get a common denominator. So my numerator is now -4 plus 28. And they both have the same denominator, so I can write it over the same denominator. -4 plus 28 is +24, and then all over 7. So 24/7 goes here. And -2 times 3/7 is 6/7. And I'm adding that to a -9, to this -9. I have to multiply -9 by 7/7 again to get a common denominator. So my numerator is now 6. -9 times 7 is -63, all over the same denominator, 7. That gives me a -57 all over 7. So let me put that here. -57 all over 7. All right, let me erase my scrap work just to give me some room here. Delete that out. All right. Finally, I want to turn this 24/7 into a 1. I make 1s by multiplying or dividing through a single row, everything. So I'm going to multiply by 7/24. The reciprocal, let me get my pen back. The reciprocal of 24/7 is 7/24 times row 2. Row 1 doesn't change. I'm only changing row 2 this final time. Row 1 stays 1, -2/7, 3/7. Row 2, 7/24 times 0 is still 0. Didn't want to change that. 7/24 times 24/7 is 1. That's the one we were looking for. And 7/24 times -57/7. The 7's reduced to 1. 7 divided by 7 is 1. And I'm left with -57/24. Let's just write that over here for a second. -57/24. 7 plus 5 is 12. Since 12 is divisible by 3, I know -57 is divisible by 3. 4 plus 2 is 6, so I know we obviously know 24 is divisible by 3. So I can divide 3 into both of these. 3 goes into 24 8 times. 3 goes into -57, -19 times. So this reduces to -19/8. So this -57 I got reduced to -19/8. Or I'm sorry, this -57/24. And where did that come from again? It was the 7/24 times the -57/7. Remember, the 7's reduced to 1. I was left with -57/24. And that reduces to -19/8. And look, this is the triangular form I was looking for. This diagonal of -1s with a 0 on the lower left. That's Gauss-Jordan elimination. Or I'm sorry, that's Gaussian elimination in a triangular form. We can use that now to solve. y presents itself on the bottom, the solution for y equals negative 19/8. And then at the top I have 1 times x, which is x, plus a negative 2/7 times y. But I know what y is. Y is negative 19/8. So I can substitute that in for y. That equals 3/7. Now it's one equation, one unknown. I can simplify this first. First of all, negative times a negative is a positive. 2 goes into 2 1 time. 2 goes into 8 4 times. So now I multiply these two fractions straight across the top, straight across the bottom. I get x plus 1 times 19 is 19. 4 times 7 is 28. That has to equal 3/7. I'm going to multiply 3/7 by 4/4 because I know I have to get a common denominator of 28. Subtract 19/28 from both sides. I'm going to get x equal, the numerator is going to be 12 minus 19. They both have the same denominator. And that becomes a negative 7/28, which reduces to negative 1/4. So I know x equals negative 1/4. Let's write it as an ordered pair. X equals negative 1/4 and y equals negative 19/8. And we'll verify it after we take this all the way to Gauss-Jordan elimination, augmented identity form. Okay, so let's, I'm going to go ahead and copy this. I'll hit pause. I'm going to copy this triangular form to the next page and take it all the way to Gauss-Jordan elimination. Let me hit pause here. So here we go. I took the triangular form from the previous page, and now we're going to continue to Gauss-Jordan elimination. It's really just one step. I want to change this negative 2/7 to a 0. In order to get zeros, you have to add rows together. First, you can multiply a row through by something, then add it, and that's exactly what we're going to do. We're going to do 2/7 times row 2 plus row 1. Only row 1 changes. Row 2 stays the same. Row 2 stays 0, 1, and negative 19/8. And row 1 now becomes 2/7 times 0 is 0, plus 1 is still 1. I didn't want to change that. 2/7 times 1 is 2/7, plus negative 2/7 is 0. 2/7 times negative 19/8, let's just write that over here so you can see it. 2/7 times negative 19/8, and I'm adding that to 3/7. 2 goes into 2 1 time, 2 goes into 8 4 times. I'm left with negative 19/28, plus the 3/7. This looks familiar, doesn't it? Plus the 3/7, which I'm going to multiply by 4/4. And I get 12/28. And negative 19/28 plus 12/28 is negative 7/28, which is negative 1/4. That's what goes here. And that takes it to Gauss-Jordan elimination, where both solutions present themselves. The first row tells me that 1 times x, which is x, plus 0 times y is 0. I have x on the first row. X equals negative 1/4. And the second row tells me that y, 1 times y is y, 0 times x is 0, it's gone. 1 times y is y. Y equals negative 19/8. Same answer we got on the previous page. We could write it as an ordered pair, negative 1/4, negative 19/8. That's the point where the two original equations cross, and really each additional new set of equations will also cross at negative 1/4, negative 19/8. Okay? Let's just verify with the first equation. The first equation from the previous page was 7x minus 2y equals 3. Let's substitute 7 times negative 1/4 minus 2 times negative 19/8, we hope is 3. 7 times negative 1/4 is negative 7/4. Negative 2 times negative 19/8, negative times negative is a positive. 2 goes into 2 1 time, 2 goes into 8 4 times. So I get positive 19/4. We hope that equals 3. And negative 7 plus 19 is a positive 12. And positive 12 over 4 does equal 3. Good answer. And we could check with the other equation, but I'm pretty confident that that's the right answer. So let's look at the final problem. Let me hit pause here and I'll go to the final problem. Here we go, final problem. It's taking 3 equations, 3 unknowns, but it's almost been completed for you. So you don't have to do a lot of the previous steps to get it to this point. So this has come a long way toward Gaussian elimination in triangular form. If you see, let me highlight here. I've got this 1. That's good. I needed that. I got a 0 and a 0 and a 0 and a 0. And I have this 1. Only thing I have left for triangular form really is to make this 3 a 1. And then I have my triangular form. That's all I need is to make that 3 a 1. So that's fairly easy. And then a couple steps away from getting Gauss-Jordan elimination into identity form. So let's do that. Let's take this into triangular form real quick. I'm just going to go off the one that's written. I'll start there and then I'll continue below. So really I just need to do 1/3 times row 2. 1/3 times row 2. And we'll continue that right here. So row 1 stays the same. And row 3 stays the same. So I'm going to rewrite row 1. 1, 0, -4/3, and 5/3. Row 3 is still 0, 0, 1, and 1. So don't confuse that 19/2. And then row 2, if I divide everything by 3 or multiply everything by 1/3, 1/3 times 0 is 0, 1/3 times 3 is 1. 1/3 times -5/2 is -5/6. Let me squeeze that in here. And 1/3 times 19/2 is 19/6. I'll squeeze that in here. And I'll write that a little bit bigger next time around. So I've got my triangular form. Let me just rewrite that real quick so we can talk about it. So 1, 0, -4/3, augmented 5/3. 0, 1, -5/6, and 19/6. And 0, 0, 1, 1. All right, so what's that tell me? I have my triangular form. The z answer presents itself. I know that z equals 1, so we'll write that down. The y answer, 0 times x plus 1 times y, so I have y. 1 times y is y. Plus a -5/6 times z. -5/6 times z, but z is 1, so I can substitute the z in. Equals 19/6. So, -5/6 times 1 is -5/6. When I add it to both sides, I'm done. I get y equals 19 plus 5 all over 6, which is 24/6 or 4. So I have my z and my y. Z is 1 and y is 4. I can go to the top row where I have 1 times x, which is x, plus 0 times y is 0. I don't have to write that down. Plus a -4/3 times z, and I know what z is. Z is 1, so -4/3 times 1. That has to equal 5/3. That's pretty simple math. -4/3 times 1 is -4/3. Take it to the other side. Add 4/3 to both sides. 5/3 plus 4/3 is 9/3. And 9/3 reduces to 3. So I can write my ordered triplet. X is 3, y is 4, and z is 1. Quick check with, I'll just use the bottom row. That says 1 times x, which is 3, plus 2 times y, y is 4, minus 3 times z. I should put a minus sign there just for continuity. Minus 3 times z, and z is 1, and we hope that equals 8. And look, -3 times 1 is -3. 3 plus a -3 is 0. 2 times 4 is 8. 8 equals 8. Pretty confident that's the right answer. All right, so I'm going to take this triangular form to the next page, take it all the way to its identity form, and show that you'll get the same answer, 3, 4, 1. Let me hit pause here. Let's hit this pretty quick. I need to change this -5/6 to a 0. I'm going to multiply row 3. I'll do it on this side. I'm going to multiply 5/6 times row 3 plus row 2. So only row 2 changes. Row 1 stays 1, 0, -4/3 and 5/3. Row 3 stays 0, 0, 1, 1. Row 2, 5/6 times 0, 0 plus 0 is 0. 5/6 times 0, 0 plus 1 is 1. 5/6 times 1 is 5/6 plus -5/6 is 0. 5/6 times 1 is 5/6 plus 19/6 is 24/6 or 4. So I jumped ahead a little bit. I'm going to do 4/3 times row 3 plus row 1. Row 2 and 3 doesn't change. 4/3 times 0, 0 plus 1 is still 1. 4/3 times 0, 0 plus 0 is 0. 4 thirds times 1 is 4 thirds plus negative 4 thirds is 0. 4 thirds times 1 is 4 thirds plus 5 thirds is 9 thirds, which is 3. Same answer.